Hello and welcome to Food Tank's webinar series. My name is Sarah Small and I'm Food Tank's Chief of Staff. I'm really excited about today's webinar with Eric Toensmeier. He is an award-winning author of the Carbon Farming Solution, Paradise Lot in Perennial Vegetables. Eric has also studied useful perennial plants and their roles in agroforestry systems for over 2 decades, and he cultivates about 300 species in his urban garden. In this webinar, Eric will discuss how carbon farming, a suite of agricultural practices and crops that sequester carbon in the soil and an above-ground biomass, can and should be a linchpin of a global climate solutions platform. This webinar will also be recorded and posted on foodtank.com as well as Food Tank's YouTube channel. You can also follow along today and participate on Twitter using #FoodTank. Also, please do submit your questions using your chat box, or you can email them to me at Sarah, S-A-R-A-H, @foodtank.com. We'll have about 10 to 15 minutes at the end for our Q&A session with Eric. So without further ado, Eric, it's truly an honor to have you here today. I'm so happy you were able to reschedule this webinar, and I'm thrilled to hear your presentation. So I'll give you the floor now.
Great. Well, thanks very much for having me, and welcome everybody. I will say that that although the webinar format has its limitations, it has a fantastic carbon footprint compared to us all getting together in the same place. So we're part of the solution right now. And I'll just to give a little bit of background, I've been studying perennial crops and agroforestry systems for about 25 years now, to one degree or another. And it was in 2009 that I started to understand their relevance to climate change, that I sort of got myself finally to read some books about climate change, and I saw that they would say things like, well, reforestation is a very powerful tool, but we can't reforest enough to do the job because we have to save land for farming. And I thought, well, there's kinds of farming that involve trees. Maybe I have something to offer here. So that began the process that culminated in the book on which this presentation is based. So very briefly, just to begin, carbon is not a pollutant. Carbon is a natural, part of our planet, and historically it has moved between these great pools of carbon: the ocean, the atmosphere, the living biomass, soil, and fossil carbon. It's moved in and out and cycled in and out of those things for, let's say, since the origin of life. And however, human activity has been moving quite a bit from the fossil pool to the atmosphere, and also clearing land for agriculture has moved an enormous amount from the soil and from the biota, from the plants and whatnot. So when you move it into the atmospheric pool, it starts to heat up the planet and cause crazy weather. And that's basically what the issue is. So it's not so much that carbon is bad, it's that too much of it in the wrong form in the wrong place is bad. And we can use these same mechanisms to bring it back into the soil pool and the biotic pool. So overall, the approach around climate change mitigation for me is that we would like to return to 350 parts per million of carbon dioxide, which is below 1 degree Celsius of warming. To do that, we need to do 2 different things, and we have to do both of them. First, we have to stop with the emissions we have today. Stop with emissions from deforestation, from burning coal, and so on. But we also have to remove the excess that's in the atmosphere, because if we want to be at 350, we're over 400 parts per million now, and we need to remove that excess and put it somewhere safe. And neither of these would work on their own. If we stopped all emissions today, we're already over a tipping point. We're already in the danger zone at 400 parts per million. And on the other hand, we can't only remove excess carbon and continue with the emissions we have, because there's a limit to how much can be stored in soil and biomass, and that limit is much less than the amount remaining in unburnt fossil fuels. So we really have to do both of these. They have to go hand in hand together. Excuse me. So there's some general agreement that there's a 4-part program for agriculture, which is one of the contributing um, uh, parts of civilization that are part of the problem. The first is to reduce emissions from agriculture. The second is to sequester carbon through agriculture, that is to remove that excess carbon and store it, which we'll talk about. The third is sustainable intensification, which is growing more on the land we have, so we don't need to clear more land for agriculture. Actually, half of agriculture's emissions come from cutting down forests to start new farmland. So if we can grow more on the land we have, we don't have to do that. And then finally, we have to adapt so that people can actually continue to produce food in the new world that's being created. So those are the four things. We're going to focus today on carbon sequestration, but I'll touch a little bit on the other ones. So this figure here shows the emissions from all anthropogenic or human-created emissions, and the green one is agriculture and forestry, and you can see it's responsible for about a quarter of all emissions. So agriculture is a very significant contributor. And it's interesting just to take a look at where those emissions are coming from. As the dark red in this figure right here is from clearing of land. The next largest one is enteric fermentation from ruminant livestock. That's cow burps, basically. And then using peat, draining peat and burning peat is third most impactful. So there are ways and strategies to address all of these, which I won't really talk about today, but that's where a lot of the discussion actually goes on around agriculture and climate, is reducing the emissions from agriculture. And there are certainly ways to address all of these. Excuse me. Second piece is sequestering carbon, which is just removing the excess carbon and putting it somewhere safe. And I'll give you a definition of carbon farming. These are agricultural practices that remove carbon. Sometimes we actually pay farmers to do this. And in some people's definition of carbon farming, it's required that they be paid to do that. I'm a little more agnostic on that, but certainly we won't get it to the scale that's necessary to address the problem without paying people to do it. Some of these practices are already ready and used on a massive scale around the world. Some are new and still under development, and they can be for very large or very small farms and different levels of intensity. The way that it works is if you think back to high school and try to remember photosynthesis, that's when plants, in the process of getting energy, they take carbon dioxide from the atmosphere and they break it. They take the carbon off. They let the oxygen back go so we can breathe it. And the carbon is made into sugars or various kinds of carbon compounds within the plant, things like the woody parts like lignins and cellulose and so on. A fair amount of it is given away within the first hour, right, exuded out of the roots to feed certain kinds of microorganisms in the soil. So some of it ends up in the soil right away. And over time, as plant leaves decompose, as the roots decompose and so on, the regular process we know of forming organic matter moves a bunch of carbon into the soil. So we see carbon in the biomass of plants, like in the woody parts and leaves of plants, and we see it in organic matter in the soil as well. Now, much of what is initially removed by plants in the atmosphere does go back, but some of it can be banked away in soil and biomass, at least for a period of up to 50 years or so, until soil becomes saturated with carbon. So we can skip this one, I think, actually. More than half of soil organic matter is carbon on a dry weight basis, and about half of above ground biomass is carbon. Very briefly, there in the book that I just wrote, I look at about 40 different kinds of practices. Some of them, so there are many ways to do this, and none of them is best. None of them is the best one or the only one or the solution to all of our problems, but each one has contexts in which it's appropriate. And I want to profile just a few here. On the left there, you can see the system of rice intensification, which is a smallholder practice. It's really very labor intensive, so it's done on small farms. It's practiced by an estimated 10 million people around the world, which means it's actually bigger than organic annual crop production, even though very few of us in the West have heard about it. And not only does it sequester carbon in the soil, but it massively increases the yields of rice, and it has some positive impact on reducing methane emissions from rice paddies as well. And on the right, we have an industrial scale intercropping system where the brown there is annual grain crops, and the green is biomass plants. These are poplars and black locusts that are cut down with machines and harvested for biomass every couple of years. So that's an intercropping system where perennials are added to annuals. And the general rule is when you add trees to any system, it sequesters more carbon, both above and below ground. Those of us in cold climates in particular have a long way to go in really fleshing out and scaling up what these intercropping systems look like. For us, most of these systems are more fully realized in the tropics. Then we have a set of strategies around livestock production. And you'll hear about livestock. This is the hot button issue in carbon farming right now. Some people will say that everyone should have a vegan or vegetarian diet. On the other hand, you have people saying everyone should eat 5 grass-fed steaks a day. And really, there's a fair amount of nuance, and there's something in the middle there. We could get into this in the questions if people like. What I will say is that there are clearly, there's no controversy over the science showing that some kinds of livestock production clearly sequester more carbon than the equivalent carbon equivalent of the methane that's emitted by the cows and the nitrous. This example here is intensive silvopasture, which is a new practice that's emerged from Australia and now is being taken up quite a bit in Latin America. And it produces 2 to 10 times more meat or dairy on the same area of land with really outstanding carbon sequestration results. So that is really fantastic. That's a great example of a way to produce livestock that is intensification in that it produces more on the land we have, which allows other land to not be cleared or even perhaps be reforested, as well as sequestering carbon. And actually it reduces emissions too, for reasons we can get into later if people would like. Our next category is perennial cropping systems. The first one is just we can convert a certain portion of the annual crops we grow and feed to our livestock and feed to ourselves with perennial crops. There's a number of perennial crops, primarily in the tropics, staple crops like the mesquite pods that you see here that can yield as well or better than annual crops and could begin to replace them. Particularly in the case of feeding livestock, it's easier to change what an animal eats than to get people to change their diet. We're pickier in what we eat than say pigs or poultry are. Whereas in temperate climates, we don't really have perennial staple crops ready to replace annual staples because their yields are quite a bit lower in the cold climates. And on the right there, we have really the highest form of carbon farming is the multi-strata agroforestry system, where you have multiple layers. In this case, the high trees are avocados and macadamias, and then there's a layer of bananas, and then there's a layer of coffee under that. These are the systems that come closest to the levels of carbon sequestration found in a natural forest, found in a real forest. And then I have sort of a miscellaneous category here. Infrastructure like rainwater harvesting and terracing are practices that can increase carbon sequestration. Productive management of ecosystems, particularly looking at examples from indigenous management around the world historically and in the present time. And then amendments like biochar, which biochar, like several of these strategies, has been oversold, but in fact has a significant role to play as part of an integrated, balanced ecosystem, farm ecosystem. Any of these practices could be, you could throw people off their land, cut down forests, and do these things in great big monocultures and cause a huge problem for climate as well as for human rights and for ecosystem services and so on. They all have to be taken in a sort of holistic context. Okay, our third was self-sustainable intensification. This is growing more on the land we have. And my favorite example of this is that female farmers receive about 7% of investment and government aid, when 93% going to male farmers. So if we were to bring women to parity, in terms of the kind of resources they receive, it would boost global food production by up to 30% without really having to change much in way of practices at all. So there's lots of ways to increase productivity, and a great many of the practices, carbon farming practices, increase yields often quite dramatically. Here's an example. Excuse me again. This is in France, where timber trees are intercropped with annual grains. In this case, you can see, I don't know, wheat or something being grown in there and with these timber trees. And what they found over the lifespan of this system, eventually you cut down the trees and use them for timber, where their carbon is going to stay in the building for a long, long time. You can plant new trees and thus keep the active, rapid rates of sequestration going. They found that systems like this, with the grain and trees together, produce as much grain and wood in 100 acres or hectares as you would need 130 or 140 to do them on their own. That is a timber parcel and a grain parcel. So this is another kind of intensification, and a lot of the carbon farming techniques do this kind of intercropping of perennial and annual or different perennial species together, and often with livestock integrated as well. And here's just an example of some of this table shows some of the different kinds of practices and their yield impacts. And you can see that they are, some of them, a few of them are lower, but mostly they're higher. And then in addition to making the yield of, typically in this case of the annual crop higher, you're also getting additional yields of other kinds. So then we have adaptation. This is really about surviving and farming in the world that is being created. And the first and most important thing to do is to build organic matter in the soil for adaptation, because it acts like a sponge to soak up water, so it can help soils. The soils that are high in organic matter tend to resist drought more effectively, for example. It also catches and releases water more slowly, as does perennial vegetation. Which helps to prevent flooding by sort of slowing and capturing and slowly letting the water trickle out. It happens that building soil organic matter is also great for yields and is also great for carbon sequestration. There are a number of these kinds of rainwater harvesting systems that can help to prevent both flood and drought simultaneously, which is pretty critical. Of course, often you have to make trade-offs. And many people are finding that changing the breeds of livestock or the varieties of crops they use is a really important strategy. And the last one, which does not sequester carbon but is important, is to offer crop insurance, so that if farmers do have a disastrous year because of climate, there's some way for them to get access to some money to help them get on into the next year. And a lot of countries don't offer crop insurance at this point. One of the key things that I try and look for here is multifunctionality. That in the photo you can see there, those are nitrogen fixing acacia trees. So that's a fast growing firewood grown as a biofuel, and they cut it off about 2 meters high every few years and use it for firewood. Underneath you can see those are taro plants with the great big leaves. Fantastic staple root crop that grows in some shade. And then they're also managing the rest of it, the understory there, by rotating sheep through to maintain, to sort of weed out and manage the understory. So there's 3 different things happening there: a staple crop, an energy, and a meat product, all out of the same system, multifunctional system, and they're getting good yields. So we're looking at ways to sequester carbon, as this example does, that improve biodiversity, that reduce deforestation, that provide benefits to the farm and to the farmer, and benefits for the wider community. To me, this is a criteria that we need to use if we're going to be investing lots of money in these kinds of efforts. We need to make it have as big an impact as possible. And the competition that we're really looking at for this is geoengineering, which are these kind of science fiction solutions, basically, which people would like to do so we can just keep on going burning all the fossil fuel we want. One example is orbiting solar mirrors, which would reflect the sun's light away from Earth and help to cool us down. The challenge with a lot of these is that they're extremely expensive, they're extremely risky, they're untested, Some of them could actually shut down the monsoon that people depend on for survival in India and in Africa. And really, they don't do a whole lot to make the lives of people, farms, and the surrounding ecosystem better. So they fail the test of multifunctionality, and even Al Gore doesn't like them, so they can't be good. Then we get the notion of climate justice, and this is a really key place where we can have an impact here. We ask the question, who's causing climate change? The answer is it's mostly wealthy countries, and wealthy individuals are vastly disproportionately responsible for climate change, and yet the people who suffer are mostly in the tropics and are mostly people with lower and lower income in those communities. These are some farmers that I've worked with in a community in Guatemala. You can see in the background a steep slope with corn growing on it. So when people are forced out of the good farmland up into these very marginal lands, they become very, very vulnerable. The weather is crazier in the tropics. That's part of it. But also people are living closer to the edge. The infrastructure is not solid in terms of being ready for hurricanes and whatnot, and often agriculture is not ready for a crisis. So we're looking for solutions to mitigate climate change that also address climate justice, which solar mirrors do not, but carbon farming really can. We talk about carbon debt, this notion that the wealthy countries actually owe a debt for climate change to the global south. And that's actually what the event that happened in Paris last year was the 21st. Now it's going to be in Marrakesh this year, in a series of meetings which are based around an understanding that that's what has to happen. All the countries sort of agree in theory that that's how it has to work. It's just working out the details are problematic. And I'll throw out that carbon farming is an ideal strategy for doing this. And here are some of the reasons why. Well, the best perennial staple crops that can, and many of the other best perennial crops are limited to the tropics. If you want to replace corn and wheat and soybeans and potatoes that produce as good a yield, but on a tree in a perennial system, really at this point, you're stuck in the tropics. The best practices, intensive silvopasture, multi-strata agroforestry systems, and more are currently limited to the tropics. Albedo is another one of the issues we look at. It's not just carbon dioxide. We look at methane and nitrous oxides and albedo, which is where the planet is dark, it soaks up more heat, and where it's light, it reflects, where it's light colored, it reflects more sunlight away and gets cooler. In far northern climates, like up in northern Canada and Scandinavia, planting evergreen trees sequesters a lot of carbon, but it actually, the net impact is more warming because those dark trees are so much darker than the snow there in the winter, that the albedo, as you get closer to the poles, becomes makes it a losing proposition to plant trees, whereas in the tropics, that's not at all true. And finally, most of these carbon farming practices are also really outstanding climate change adaptation practices. And for an individual farmer, let's say in West Africa or in New Guinea, they're not really concerned about climate change necessarily. They're not trying to mitigate it on their 2-hectare farm. They need to be able to survive. They need to be able to continue to produce and have revenue off of their farm and have food and materials off of their farm. So these are very good strategies for that. So there's really you can make a strong case for carbon farming as a key way to address climate justice and climate debt, which is great. Not that there aren't cool things we can do in colder climates as well, but the best things are currently limited to the tropics. So what could possibly go wrong with such a great idea? Well, so many things could go wrong. The first one we see today, which is let's talk about oil palm and sugarcane for a minute. We see slavery on farms in Malaysia producing oil palm. We see slavery in Brazil on sugarcane operations in the name of green energy, bio-based energy. Healthy forests are being cut down, converted into monocultures with a huge net loss. And in many cases, there's slavery and murder and displacement of indigenous people and all kinds of terrible things happening. So doing any of these things in a sort of industrial monoculture mindset is not a success. There are challenges in converting to perennial systems, in that you're looking often for at a couple of years until you're ready to implement. I'm sorry, until you break even on them. Particularly if you're planting trees, are not going to make food right away. You have to wait some. There are regions in the world where water is a really limiting factor for agriculture, and there just isn't enough water to plant a bunch more trees, for example. If we get warm enough, if we hit somewhere around 3 degrees Celsius warming, and we're now at about 1 or a little over 1, um, certain ecosystems, instead of becoming a place for sequestration, actually off-gas their carbon dioxide. Like at 3 degrees, there's about a 50% chance that the Amazon turns into a desert. So any work you did to do carbon farming in a region like that, when it dries out, if it becomes a really dry area, or otherwise is wrecked by the ravages of catastrophic climate change, the carbon you sequestered is lost. And it should be mentioned that all of these agricultural sequestration techniques are temporary and reversible. As long as you take good care of the soil, that carbon will stay in there. But if you start tilling again, if you do bad grazing practices, it can be reversed. So nonetheless, with good management, the carbon can remain in the soil for centuries, which is plenty of time as far as I'm concerned. And many of these trees live for decades or centuries as well. So that's enough time as far as I'm concerned. There's a chance also, I think, that people are scared about climate change, which makes sense. And we want something that's just going to make it get better. And you hear a lot of pitches like this. You've heard it for biochar. You've heard it for holistic grazing. If everybody just does this one thing, we'll solve climate change, and we can keep on going with our civilization looking as it does today. And really, there's no way out of climate change without transforming every aspect of civilization. Really, in the next 2 decades or so, it's a fairly big project. So we can't let this make us complacent. There's some concern that some of the species used in carbon farming could become invasive species. It's not something I'm particularly worried about when you consider that we may be losing perhaps a third or so of all ecosystem types, of all habitat types, when we get to 3 degrees or so of warming. I'd rather save an ecosystem and have it have some invasive species in it than have the entire ecosystem completely gone. And finally, some of these practices and some of the perennial crops are still under development, and really aren't yet ready for prime time. That's much more true, again, in colder climates than in warmer ones, although we have some great things for cold climates now. So how much impact could this really have? Well, a recent study by Ratan Lal, who's one of the great scientists in this area, found that doing just the sort of annual cropping systems, like better annual cropping, be it organic, be it conservation agriculture, no-till with rotations and green manures or so on, that could give us 41 parts per million of the 50 or more that we need today. Grazing land also has a contribution that it can make, although it's not as big as we had initially thought. It does have a legitimate contribution. And given that we know that the kind of rates, in this talk, I'm not talking about the rates of sequestration particularly, but they vary enormously. Between most of the annual ones might give you about a half a ton per hectare per year. And some of these agroforestry type systems can give you 5 or even 10 times that much per acre, per hectare, per year. And that gives us a lot of hope. It doesn't work without reducing all those emissions, without overhauling buildings and transportation and energy and everything else. But there is a real potential for agriculture to play a very serious and significant role in climate change mitigation. And I'll add that there is now some money coming down, currently some money in this, and we're going to be seeing increasingly very large amounts of money coming towards agriculture. Right now, the money that goes through the UN climate finance system is about $360 or $370 billion a year. About 2% of that goes to agriculture. Almost all that is for reducing emissions in agriculture. But given that agriculture is responsible for up to a quarter of emissions, it makes sense that we're going to see an increasing amount of money coming to the scaling up of these billions of dollars, I suspect, will be coming our way in the next couple of decades to really scale up these regenerative agricultural practices. And finally, if you'd like to learn more, of course, you could read my book. But I've put together a lovely website for it, which is carbonfarmingsolution.com. I have videos about maybe 30 or 40 of these practices. I have videos. I have a ton of recommended readings on there with links to where you can read them. So you can get lots and lots more information there if you like. And I think with that, we can move on to some questions, and I'll stop my screen share if I can figure out how.
Great, thanks, Eric. Your video is on now, so we see you.
Oh, great. Okay. Hi, everybody. That's me.
Hello.
That's what I look like. I have a face.
So thank you. Thank you for that informative presentation and for sharing different aspects of carbon farming with us. We do have a lot of questions to get through, so for the next 10, 15 minutes or so, we'll go through as many as possible.
Great.
So I wanted to start by asking you a question from a listener, which reads, how can carbon be reduced in more urban settings? Are urban farms making a significant difference?
Sure. A couple of answers for that. The biggest contribution from urban agriculture is reduction of emissions, because when you're not bringing in food from farther away, you have less emissions. And when you're right in the city and people can walk or bike or take the train or the bus to your farm, that's the best case scenario. Another real opportunity in all of these carbon farming practices will work in a city if you have the right amount of land and context in order to be able to do them. Although the area of land is somewhat smaller, the total area is somewhat smaller, but the level of intensiveness that is typically found in urban farms is outstanding in terms of very high yields in this small area. The other piece about cities is that there's a huge opportunity around diverting waste, food waste and other waste that would end up in the dump. That releases a huge amount of methane when it's in there, can instead be composted, can be fed to pigs, can be fed to chickens, and so on. Various kinds of biomaterial, be it used paper or wood trimmings and all that kind of stuff, also has great potential for composting or mulching or otherwise removing it from the waste stream and getting some of its carbon into the soil in cities. So that'll be my short take on that.
Great, thank you. Our next question comes from Molly. She asks, what can food companies do to promote carbon farming?
Excellent question, and we're starting to see that more and more. In fact, Kiss the Ground, which is a sort of another carbon farming type organization, is starting to work on really figuring out how to make this happen. And I'm seeing that a lot of places are trying to figure out how to source materials, whether it's ingredients for food products or bio-based plastic or what have you. What we really need is a hub to connect producers with or producer associations with businesses. But yeah, you can try and source the stuff from the best possible place. And often farmers need some financing in order to be able to take a step up to do this. If you're looking at 2 to 5 years for almost any of these practices before farmers are breaking even, if we can help to finance them to make that change, and often creditors do provide finance to producers for that sort of thing, then that would make a big difference. Or maybe it's about financing some regional processing facilities or something like that. That's a great question, and love to talk more about that sometime.
Great, and our next question reads, it's a similar lines here. Are there any farmers, companies, or organizations implementing carbon farming well and seeing good results both by sequestering carbon and maintaining yields?
Sure. Yes. Let's see. And I in the book I have, and there's some on the website, some examples of how widely some of these are practiced. Some of these things are being done on tens or millions of hectares around the world, and a hectare is about 2.5 acres. So shade coffee and shade cacao would be great examples of extremely high carbon systems that are often associated with fair trade and other kinds of good things. Certainly grass-fed livestock generally tends to have a net carbon sequestration, although not a huge one, but some. Organic stuff tends to have good carbon sequestration as a general rule. What we don't yet have is people aren't really branding themselves as this came from an agroforestry system, this came from conservation agriculture, this came from such and such a carbon friendly system. And I think we're at the phase now where producers, producer associations, processors, businesses, and end retail need to start collaborating together to figure out how to bring this to people's attention. Because even where people are producing silvopasture, which is trees with pasture, which has a much better carbon impact than managed grazing alone, much more powerful, 5 or 10 times more powerful. I've been unable to find anybody branding their product as such, even though there are 450 million hectares around the world. That's what around 1 billion acres around the world in silvopasture, and yet you can't find anybody who will market it and say that that's what it is. So we have to there's a sort of finding each other in the dark and holding hands and figuring out how to turn on the light that we sort of have to do in order to really bring some of that commercial potential out at this point, I think, with some exceptions. Lotus Foods, for example, is a rice company that sells rice from system of rice intensification. They don't talk about its climate impact, but they talk about the other social and ecological impacts from it. So we just need to see lots more of that. And Kiss the Ground is really beginning to start that conversation. So I'll end that one there in the interest of time.
That's wonderful. Thank you for those examples. And so our next question is from a listener, reads, what are Eric's preferred ways to measure soil carbon sequestration, especially in the context of livestock silvopasture? Maybe just to recap for our listeners, silvopasture is combining trees with forage and livestock production.
Great. Well, the easiest thing to do is measure your soil organic matter, and if it's increasing, you're sequestering carbon. However, people disagree a lot on, people will say every percent of it you increase means this or that many tons per acre or per hectare. And I find the numbers people come up with on that have quite a bit of variation in them. So we're still waiting on that. But clearly, if your organic matter is going up, which your regular old soil test will tell you, you're moving in the right direction. It won't tell you how much the emissions are coming from your animals, particularly. We're still waiting on a good, affordable, mass-produced, easy soil carbon monitoring tool. A lot of people are working on them, but we haven't really got the perfect one out yet. And scientists are actually still arguing with each other a little bit over the best ways to measure carbon in the soil. Above ground biomass is pretty easy. They have that worked out. How deep do you measure and which kinds of carbon you measure and so on. They're still fighting, but they're nearing agreement. That's the best I can say for now.
Thank you. Our next question comes from our listener, reads, what policies are coming online to keep carbon in the soil long term? Land trusts, easements, question mark.
Sure. Oh, that's a good one. Let's see. Well, land trusts and easements don't necessarily mandate what kind of farming you do. So you could still be plowing out there and releasing all that carbon. Let's see, I should say organic systems with plowing can still increase carbon dioxide because of the intensity of use of green manures and cover crops and compost and so on. But typically plowing is really the enemy of soil carbon. An example from the United States would be the Conservation Reserve Program, where they pay people to take land out of production and put trees in. The Natural Resource Conservation Service of USDA has a number of programs where they will pay farmers to implement certain conservation practices, be they agroforestry or strips of perennial grasses or riparian buffers along rivers and streams to protect water quality that also have a carbon sequestration impact. We don't have anything in the US currently that is paying farmers to do anything for the purpose of carbon by the government, by the federal government, because our federal government can't agree whether climate change is real or not. However, California is building a carbon offset trading program. I don't really like carbon trading, but I'm interested to see what California is going to do. And that will include some payments to farmers for implementing these practices. But it's not hard to imagine how a land trust might include, as they often do, standards for the way in which things need to be farmed. Particular practices need to be implemented as part of the agreement with the land trust or as part of the long-term lease. And then it would just be a matter of making sure that you enumerate, that you spell out in the agreement what kinds of practices are and are not permitted to be done on the farm, and that would essentially reserve that carbon in there, barring some kind of a natural disaster. Would encourage it to be in there for the long term. All right, what else?
Okay, so our next question is regarding the US. So, how important do you think it is for the US specifically to join the 4 per thousand initiative, or do you see it as mostly symbolic?
Well, I think it would be important symbolically for the U.S. to join. And we're about to see a lot more out of this campaign in terms of they're convening a group of scientific advisors, and they're starting to really go from, hey, wouldn't this be a lovely idea, to, hey, what does this actually mean to sign on and participate and be part of this? They're still figuring that out, but they've got some very, very, very good people, some of the best folks in the world working with them on this. So I think we'll be seeing something. And yeah, it'd be great if the U.S. Signed on. I don't think, I'm not certain they would be able to do that without congressional approval. And depending on how things go in November, that may or may not be possible. And we'll see if it really turns out to be a significant movement or not, if it turns out to have significant results or not. I'm sort of guardedly optimistic about the potential of that campaign, and particularly seeing that they have people like Ratan Lal and PK Nair getting involved. I think we're going to see some good things from it in the future.
Great. And our next question reads, how are you or others spreading methods, training, and instruction on how farming operations transition towards carbon farming? And maybe a good insert here too, Eric, for how people can purchase your book.
Oh, sure. Okay. Yeah, you can get the book from Chelsea Green. You can get the book from wherever you normally buy books, your local bookstore or your online retailer or whatever. You can get it from them. It's available as an electronic book as well. That's been my main contribution until lately. I teach courses and stuff too, but let's see. Well, actually, the U.S. Department of Agriculture has regional climate hubs set up, and they do provide training and education. And a number of the practices that are promoted by the Natural Resource Conservation Service of the USDA happen to sequester carbon. They're not allowed to pay you for it for that reason, but they can pay you to help you get it set up, and they can train you and so on to do that. Elsewhere in the world, in Mexico, for example, there's an active program to assist farmers to switch from pasture to silvopasture. India has a huge national agroforestry program. They want to go from 25% forest cover to 33% forest cover nationally, exclusively through adding trees on existing farms, adding working agroforestry trees on existing working farms. Brazil has some really fantastic policies, including they have sort of like a smallholder carbon farming type program, and they actually require that public schools buy at least a third of their food from those farms. So Australia has a national carbon farming policy that was initially paid for through a carbon offset program, which their new conservative government has thrown out, but they kept the carbon farming program because it was really popular. So I'm starting to assemble more and more of these examples of successful policies, and each country that signed on to the Paris Accord has to prepare a national, what's it called, the INDC, intended nationally determined contribution, basically a plan that says what they're going to do for mitigation and adaptation, including agriculture and land use. So that represents a real opportunity to work with countries to get this kind of stuff implemented. And my hope is to worm my way more and more into the next IPCC report, which is where they actually set the numbers. There's an official methodology that IPCC uses that all of these countries have to do their record keeping and reporting in. And I'd like to see more of these carbon farming practices included and see their sequestration rates. A lot of them are so low, so conservative as to be barely present in terms of the rates, and not in agreement at all with the stuff you're seeing in the peer-reviewed literature at this point, many of them. So I guess that's a little bit of a rambly answer to that.
We have so many good questions here today, Eric, so let's try to get through two more. Our next question comes from, I assume he's an urban farmer, his name's Joel, but he asks, what would you recommend for toxified urban soil where buildings have been plowed into the earth, low carbon content, and poor percolation?
Sure. Well, I farmed that way here in my city for a long time. The first thing you want to do is make sure there's nothing poisonous in there, or you shouldn't really be messing around with it at all as far as food, like lead or whatever. Sometimes it's low enough that it can be remediated. Sometimes you have to sort of dig it up and bring it somewhere else where they can handle that kind of material. Sometimes you can sort of pave it over and put raised beds on. So if it's really poisonous, that's one issue. But in terms of just like crushed brick or whatever, there's a lot of crushed brick soils in my town. A lot of the things that we know, cover cropping, mulching, composting. The nice thing in the city is there's so much waste. There's so much food waste and cardboard and paper and so on, and often water, roof water. That's just turning into a flooding problem. That we can really build fantastic compost and build up soils relatively quickly by tapping into that urban waste stream. I guess I'll keep that very short like that for now, and we can do one more.
Thanks, Eric. So our last question for today reads, on the consumer end, is there a way for us to know whether our purchases are from a company or farm that is sequestering carbon versus disregarding environment? And so I think at the end of your presentation, you also touched on kind of, there's not this label that exists yet on our food, but maybe you could discuss that way forward.
Sure. Yeah, I would really love to see a certification program, a carbon farming certification that would say, this sequesters low, medium, high carbon or whatever. Starting a certification program is a no joke kind of a project. It's a big challenge. If somebody in the audience wants to do that, they should send me an email and I'd be happy to advise them on my thoughts on how I might do it. Really, I mean, organic is generally going to be carbon sequestering, at least to a small degree. Grass-fed is generally going to be carbon sequestering. Anything perennial is probably good. Fruits, nuts, and so on are generally going to be having a positive impact. But really, we just really lack the basic information of, does this come from, how is this being farmed in terms of carbon? And we have to, I think we're going to see innovative individual companies coming out long before we see an international certification system. But I think that's a necessity to allow the consumers who do have the comfort and income to be able to do that, to choose and support those farmers, and ideally not only support them by purchasing their product, but paying a little price premium on it as well. I think that would make a big difference for farmers in being able to convert, and it would also be a way to reward people who've been doing the right thing and not getting a price premium or not getting access to any better markets because of what they're doing.
Great, and unfortunately we've run out of time today, but thank you so much for joining us today, Eric. It's truly been an honor to listen to all of your knowledge in this webinar, and there were just a couple of standout points to me that I just wanted to recap for our listeners. And you had said earlier, agriculture can play serious and a significant role in climate change mitigation, which is, I think, really powerful. And then another point that stood out to me was, you had said, no, there's no way out of transforming climate change without transforming civilization. And so it'll be really interesting to see how this plays out into our future of the Earth. So thanks again to all of our listeners for sending in your questions. We couldn't have had this Q&A portion without you. So it's been a pleasure, and thank you all again. You can register next week. We have 2 webinars, double week, and you can register on foodtank.com. So thanks to everyone again, and have a great rest of your day.